Hello everyone. In this tutorial we're going to be doing an introduction to earscript, which is here. Earscript is the script behind the procedural generation in EternAlgoRhythm, and it is maybe not the easiest to use, but it's also not too complicated. So let's see how it works. Here I can return to the editor and go to the earscript test page where we can see what is going on. So first things first, we have comments. If we write a octothorpe symbol, like in Python or like in JavaScript, we can write a comment. And then everything else other than comments are tokens, and each token has a head and a tail. So for example, this +5 is a token. The plus is the head, it's the beginning, and the 5 is the tail. If a token has no tail, so for example I just write plus, then the tail is 1. So for example, every time you saw that I wrote dot, this was also .1 behind the scenes. The first couple of tokens that are useful are the equals and the dot. So what equals does is it sets this number here to the number, and dot then returns a number. So if I do equals 6 dot equals 7 dot equals 5 dot equals 4 dot, what we should see is that when we do a step, it gives us a 6, then it gives us a 7, then it gives us a 5, and then it gives us a 4, because it's setting this number to 6, then returning the number, then setting it to 7, returning the number, setting it to 5, and setting it to 4. So overall we end up getting 6, 7, 5, 4. Okay. The next few tokens that are useful to know are the plus and the minus. So let's say that I have a 6 dot, then I can do plus dot, minus dot, minus dot, and this is going to increase the number. So if now I do a step, I am in 6, then I'm going to increase by 1, increase by another 1, decrease by 1, and decrease by another 1. We can also do +2, +2, -2, -2, and we get what you expect. We start at 6, then we go up to 8, then all the way up to 10, then back to 8, then back to 6. Okay. Now let's look at loops. So loops, there's a couple of useful loops that we'll introduce now. There may or may not be more, but for now, let's first learn about the infinite loop. So if I can set equals to 6 dot equals to 5 dot, this will be setting the pointer to 6, then to 5, and returning each step. However, it's also looping forever. So we get a 6, then a 5, then a 6, then a 5, then a 6, then a 5, then a 6, then a 5, and it will continue on forever. If we run, it'll take longer because it's running a long time, and you can see that it continues to do 6, then 5, then 6, then 5, then 6, then 5. Okay, maybe we don't want to loop an infinite amount of times. Maybe we want to loop 4 times, and so instead of an I, we write a 4. And so if I write a equals to 4 dot, then when we compile and run, then we get 6, 5, 6, 5, 6, 5, 6, 5, 4, because it only loops 4 times inside, and then it goes outside. Yeah. Next, now that we have loops, let's make it an infinite loop again. I notice that I'm doing like equals to 6, then equals to 5. Maybe let's make it a finite loop. So what if instead I use what I call a sequencer? Let's make an infinite loop again. So the sequencer is going to use brackets, and I'm gonna set it to 5. Well, set it to 6, then set it to 5, then set it to 4, and then I'm gonna do a dot. So what it's going to do is it's going to loop through here and go, the first time it loops, it's going to pick the 6. The next time it loops, it's going to pick the 5. And the next time it loops, it's going to pick the 4. Yeah. And then a 6 again, and then a 5 again, and then a 4 again. 6 again, 5 again, 4 again. This is useful if you have some patterns, like maybe I have a 0 and then a 1 every loop. But some loops start with 6, then with 5, then with 4. So if we compile and run, we get 601, 501, 401, 601, 501, 401, and so on and so forth. So these sequencers are quite useful inside of loops. There's another type of, it's similar to the sequencer, but it's what we call a randomizer. And here, just like this infinite loop has this I, this randomizer has this R. And what this randomizer is going to do is each time it gets here, it chooses randomly one of these 3. So if we compile and we step, we get a 6, then we get a 4, then a 5, then a 4 again, then a 5 again, then a 6 again. And if we run it, we see that there is no pattern, it's just choosing randomly between them. Yeah, and now we have quite a lot of new tools that we can use in our collection that we were working before. So to open the collection, we click Open Collection, we choose the collections, My Collection.cll, and now we're going to go to the base. And so now we know that here it is going to be starting at 0 and sending a dot, but the base and the chord have both 4 notes. So let's go, we set it to 0 at the beginning, and then we dot. Then we go up by using plus, and then we dot. And then we go up again, and we dot. And we go up again, and we dot. And now we save, and now let's see what the bass is doing now. Now the bass is going up every time, which is quite an interesting pattern. Next, what we can do is look at this chord, which we haven't done before, but we know how to do it. We know we start with a label, with Control L, we write a start, then we make a passage, we connect the 2, and we're going to write the following, an infinite loop. And it's going to be very similar to what we did for the bass. We set it to 0, and then we dot, and then we plus, and then we dot, and then we plus, and then we dot again. And one more time. Yep. And so this is going to go through all of the chord notes. Let's change the chord instrument maybe from a grand piano to a to the strings. Yeah. So it's also going up, but now what we want is instead to have everything at the same time. So this dot we know is actually a dot 1, and that dot 1 is what is called a tap forward. If I press F2, or here in the cheat sheet, I know that this dot or dot 1 is the tap and forward, whereas dot 2 is only tap and dot 3 is only forward for silences. So here's what we're going to do. We're going to add the silence with a dot 3, and that instead of this being a dot 1, this is going to be a dot 2. This is also going to be a dot 2, and this is also going to be a dot 2. And this is going to be both a tap like the dot 2s and the forward like the dot 3s. So it is going to stay as a dot 1. And now this is what we get in the chords after we save. now let's do some drums. So the way drums work is by, well, as always, we make a label, we call it start, we make a passage, and we open an infinite loop. And so here what's going to happen is that we have the equals to 4 dot is the kick drum, whereas the equals 5 is the snare. And so what we're going to do is we're going to make a sequencer, which goes first the kick drum, and then the snare. And then what it's going to do is use one of the various hi-hats. So it's going to randomly choose between the hi-hat 6, the hi-hat 7, and the hi-hat 8, and then also press it. So let's see what that sounds. It should be a kick drum. In the first loop, it's picking the kick drum, then it's picking one random hi-hat, and then it's going to take the snare, a random hi-hat, then back to the kick drum, and so on. Yeah. And finally, let's make a more interesting melody. So what we're going to do is we're going to make an infinite loop, where now we're going to, at the beginning of the loop, randomly choose between starting at 6, starting at 7, and starting at 5. We're going to make a dot. And instead of randomly choosing, let's say we just sequentially choose between these 4. But then what we're going to do is we're going to randomly go up or down by using this randomly plus or minus, and then a dot. But we're going to do this 3 times, and instead of copy pasting, we're going to make a loop. So it's going to choose every 4 notes is going to pick randomly, or not randomly, sequentially between these 2. And then it's randomly going up or down by 1. So let's see how that looks. And once again, we'll end with a small playtest because it's always fun to do. Thank you so much for joining this video, and we'll continue. There is still more to learn. Thank you. Bye.